The grommets that we're going to be using on our robot are going to be modeled as a revolved feature. So we'll go ahead and begin by opening up a new part file, and we'll start out by sketching on the top plane. So we'll click on our top plane, click on Sketch, and here we go. The grommets are going to be supplied by McMaster-Carr. Here's the part number down here. You can look it up on the web. McMaster-Carr also supplies all the dimensions and a rough drawing that we're going to use to model our part here in SolidWorks. Now, the theory behind a revolved part, we're going to take a closed profile like a square or a circle or any closed profile that you can imagine, and we'll revolve that around an axis, which will create the solid. Now, to do that, we're going to only model one half, the right half of this drawing, using these dimensions down here. So we'll begin by creating a rough approximation of the right half, ignoring the roundovers. So as I'm sketching, do you see the yellow constraints to the right of my cursor? I'm using those to my advantage because they automatically constrain the lines as I'm sketching them on my sketch. And there we go. So now here's a rough approximation of the grommet. The roundovers are these small radiused edges you can see here on the McMaster-Carr drawing. We're going to add those later on. But right now let's go ahead and constrain our sketch. We're going to begin by drawing a center line. So we'll go ahead and draw a center line from the origin to the center of this first vertical line, and another one from that line to the center of this other vertical line. We'll go ahead and hit escape and exit out of the center line command. Now we can click on these center lines and add a horizontal constraint to each of them. Okay, what other lines are out of alignment? They should all be either vertical or horizontal. So this guy needs a vertical constraint, and this top line needs a horizontal constraint. Alright, now looking at the McMaster-Carr sketch, the top is symmetrical with the bottom, and we're going to use that to our advantage. Whenever we can use symmetry, let's go ahead and use it. So let's go ahead and select this top line, and we'll hold down Control, which allows us to select any other sketch object. So holding Control, I'm going to left click on this bottom line, and I'll release Control, and this little menu pops up if I don't move the mouse too fast that has a list of the constraints I can add to these two objects. If you do move the mouse too fast or move away, it's also here on the left side. So we'll go ahead and make these two collinear, which means they're on the same line as each other. And I think that's it with constraints. So we'll now dimension this to size. In order to dimension the grommet, I like dimensioning my sketches inside out. So we'll start with the smallest inner dimension, which will be A, and then I'll go to E and then B. The reason I don't like going from outside in, if we begin with B, I'll show you right here. If we draw our sketch too big, our rough approximation too big, it sometimes has the tendency to provide you with unexpected results. So we'll go ahead and dimension this. Now, half of B, B is 1 inch, and that's the outside diameter of the grommet, so we can do half of B, which is half an inch, but also our input field here acts as a calculator. So we can actually type in B, which is 1 inch, and divide that by 2, which we all know is half an inch. Now, when I dimension that, did you notice that this line here is now ahead of B, which is not what we want? So we can go ahead and actually click on it and move it back into place. Or we can just begin by dimensioning from the inside out, which is what I like doing. So we'll go ahead and click on this dimension and just delete it. So we'll start off with A, which is 9/16 of an inch, So we'll go ahead and right click, Smart Dimension, and we'll dimension from the origin to the first vertical line, the inside diameter. And we'll click out here in space. And we'll set that as 9/16. So like I said, this field is a calculator, so we can put our 9/16 in parentheses. 9 divided by 16 divided by 2, because we're only doing half of the sketch. And this is what we get, 281 thousandths. Now, since all our dimensions are fractional, let's go ahead and change our dimensions to fractional. We'll change from decimal inch to fractional inch. To do that, we go here to Options, and under Document Properties, you can click on the units, and for the right now we're using decimals, so for fractions we'll make our smallest fraction a 32nd. So we'll just type in 32 and hit OK. And so now our 281 thousandths is now 9/32. We'll go ahead and dimension E, which is the panel hole diameter, which is 3/4 of an inch. So we'll click on the origin and click on the smaller inner vertical line, and we'll click down here, and this is a calculation field, so we can do our parentheses. 3 divided by 4 divided by 2, and that gives us 3/8. We can also just type in 3/8 if we can do the math in our head. And now for this outer dimension B, we can go ahead and click on this line and our origin, and B is 1 inch, so we can just type in half an inch, 0.5, and that's half an inch now. So let's go ahead and dimension the vertical lines here. So we'll begin on the inside here with a D, which is the panel thickness. That's 1/16, so 1 divided by 16. And we don't have to divide this by 2 because we're using the full length here. And the overall thickness, so we'll click on the top and the bottom, and that's 5/16. Alright, let's go ahead and clean up our dimensions a little bit, and we'll bring them in so we can actually see them as we zoom into the part. Alright, and here we go. Now we have the roundovers. Now they didn't dimension the roundovers because they're not a real critical feature. So what we're going to do, we're going to use the sketch fillet sketch feature, and it's going to ask for entities to fillet. So we can click on 2 lines that we want to fillet, or we can just simply click on the corner that we want to fillet. And we'll leave it at the default 100,000ths of an inch since it's not a critical dimension. And we'll go ahead and green check mark. And now we have our roundovers and our profile fully dimensioned. So we'll go ahead and green check mark. And now we need to add our axes of rotation. So we'll create another vertical center line. We can just click out in space. It doesn't really matter where we click. Also, if you want to end a line, you can just double click and that ends the current line command. So if you're drawing a series of lines and you want to stop here, you can just double click and that stops the line command. And we'll just delete those. So we can go ahead and exit our sketch now, and in our Features tab we'll go to the revolved base, and it's going to ask what sketch do we want to revolve. So we can just click on the sketch we just had, and it just chose for us some arbitrary axes of revolution. So we can go ahead and delete that, and we'll click on our vertical line that we created, and here is our grommet. Now with the revolve feature, we can choose how many degrees we want to actually revolve the part. And just like the extruded base, there's the select contours, thin feature, and other directions that we can use. but we want a full rotation, so we'll do 360 degrees and green check mark. So here is our grommet. Now let's go ahead and change it from this ugly gray to the actual color it's going to be, and to the actual material it is. So we can right click on material, and our rubber on the McMaster-Carr website, it says it's styrene butadiene rubber. So that is under here. We can go to edit material and look under the rubbers. So styrene butadiene rubber, SBR. So we'll go ahead and select that. It has our density and tensile strength in here. We can apply that and close this, and it's now a white color. And in order to change the colors, you can right click on the part, click on the colorful ball, and click on the part. And now we'll change it from a white to a charcoal gray, which is a more accurate representation of our grommets. So here is our grommet. Now to double check that we did our sketch right, we can go to the Evaluate tab and we can measure. So if we click on a round surface here, it'll give us the area, the diameter, which is 9/16, which we have here is A. We can click out here on the white space. We can click on a little flat section here, has a diameter of 1 inch, which is our B dimension. And if we click on the inside, we have a diameter of 3/4 of an inch, which is our panel hole diameter here. So we did everything right. So here is our grommet.